Hello everyone, my name is Dongwook Kim from the Korea Internet Security Agency. First of all, thank you for allowing me to present myself in front of you. These four sections of the agenda will be our presentation subject. Let me begin with initial infiltration. The Operation Bookcodes attack started in April 2019. The operation targeted specific companies in Korea that resulted to numerous CNC firms. Our investigation began using documents that include remotely controlled malware, which were acquired in January and February of 2020. The common ground was documents were saved under the names of public institutions related to the domestic maritime industry. The contents suggested that the attackers pretended to be employees of the public institution and attempted to attack marine-related companies. As I have shown you in the previous slide, we investigated the incident regarding the CNC servers and victim system for about 5 months. The figure on this slide shows how the attacker configured the attack network, which were found during our investigation. The attacker created an MID server to manage infected system and configured multiple CNC servers for remote control and command transmission. They attacked specific groups, including the media and security software development companies, in addition to companies related to the maritime industry. It was also found the attackers exploited web servers using their CNC servers among the infected system. We found two malware distribution scenarios in Operation Bookcodes. Case A shows malware distribution by attaching documents. When the victim opens a HWP document for the first time, remotely controlled malware is installed in the victim's computer. Afterwards, the malware downloads a dropper, another malware, by communicating with the malware distribution server and executes it to infect the second malware. In this case, the second remotely controlled malware executed by the dropper was the same as the first one, used for initial infiltration. However, the difference from the malware used for initial infiltrations was that the second malware was secured with continuity. The second malware registered a launcher in the registry, so it is executed every time the infected system is booted. After going through this process, the attackers collect information and spread malware throughout the target organization. Case B shows malware distribution using a link in phishing emails. When the recipient clicks the link, it redirects to a malicious website. Then, the website checks whether the access IP is target system's IP address. If the IP address is found to be originated from the target, the system downloads and executes the malware. This slide shows the distribution process of case A in detail. When the victim opens the malware-infected documents for the first time, it will execute a shellcode inserted in the document. Then, the shellcode injects a backdoor into the document memory and executes it. At this time, the backdoor sends the information of the infected system by communicating with the CNC servers. When the information is sent to the attackers, then they determine the level of importance of the infected system until they download and execute the dropper in infected system. 3 files are created when the dropper is executed. INF file contains the list of CNC server addresses, while DLL file is the encrypted malware launcher. DAT file is an encrypted, remotely controlled malware. The dropper registers the launchers in the registry to automatically execute the launcher when the infected system is booted. Then the launcher decrypts the encrypted, remotely controlled malware, injects it into the process, and executes it. The executed malware reads the CNC server addresses saved in the INF file and starts communication with the servers. The attackers made it easy to replace the server addresses by changing INF file only. Here, you can see the distribution process of case B in detail. Phishing emails induce victims to click the link via Internet Explorer. By looking at the attackers requesting to use a specific browser, it is assumed that the vulnerability of the specific browser was exploited to download the malware. When the victim clicks the link, it redirects to an infected website. The web page checks whether the access IP matches its target IP addresses through MD5 conversion. If the victim's IP address matches the target IP address, the victim is redirected to another website that downloads another malware to conduct malicious behavior. The next topic will be shared by the next presenter, Tae-woo.
Greetings, I am Tae-woo from the Korea Internet and Security Agency. In this chapter, I will further explain the malware used by Operation Bookcodes. Malware can be largely classified into dropper, downloader, and bookcode RED. This slide explains a type of malware called dropper. The dropper behaves according to two option values. The G option collects the list of services in the net SVC group inside SVC host and retrieves the service names that are not currently used in the system. The S option registers the launcher file in the registry for automatic execution and executes remotely controlled malware. The registry name, DLL file name, and RC4 key value used for decryption are used as command line argument. Here, one of the service names that are not in use, which was identified by using the G option, is selected or registered as the registry name. Next is the downloader. The downloader uses an encrypted download address and path to download a file as argument values. When the second argument, an encrypted string, is decrypted, the downloader can check the primary and secondary download address that will be accessed by the malware. The attackers use an algorithm that customizes the DES algorithm. You can see here how the downloader works in detail. The downloader sends the information of impacted device, the encryption key, and the secondary download server address to the primary download server. Then the primary server decrypts the secondary server address, connects to the secondary server, and download another malware. And last but not least is the remotely controlled malware. The remotely controlled malware consists of three files, which are the launcher, encrypted malware, and CNC server address file. The launcher decrypts the encrypted malware and executes remote control functions. At this time, the CNC address list is retrieved from the IENF file. Malware execution is logged in the server dll.log file. The operation book code collects the information of infected system when executed for the first time and send it to the CNC server. The figure here shows the data structure when sending the information of the impacted device. The figure on this slide shows the data structure when sending remotely controlled commands. The remotely controlled malware consists of a total of 24 commands. For example, the command is 0x978533653 in the current slide. This is a command that performs a cmd command and returns the result. The primary argument contains the content of the command to be executed. The secondary argument contains a file to have the execution result. Next, we will analyze the servers that exchange command with the bookcode. The bookcode controls the infected system using the CNC servers and the middle server. The CNC servers are used to directly execute control commands to the infected system while the middle server is used to manage multiple CNC servers. The operation structures I have explained earlier are combined to create an overall framework as shown in the figure. The web server among the infected systems is used again as a CNC server or a watering hole page to continuously increase the remote control source. This slide shows the files found on the CNC servers. The release.asp file performs a direct connection with the bookcodes and was controlled by the mid server. The config.dat file manages the IP address of the mid server. Although file names were different for each CNC server, the argument value bookcode used for command and control was the same. That is why we named it as the operation bookcode. The attackers also created and used a watering hole server for initial infiltration. In the first phase of the watering hole attack, connection was redirected by inserting a simple malicious code script. In the second phase, a DLL injector was used to inject malicious functions into the W3 SVC service running on the server. The malware injected to the W3 SVC service monitored all incoming packets from the web and downloaded the malware when a specific request was received. Lastly, let me tell you about some characteristics of the operation bookcode. We could identify the commands used by the attackers in the impacted system by monitoring the packet exchanged between the CNC servers and the bitterms. Here are some of the commands frequently used by the attackers. Upon analyzing the commands, we could see the directory of the attackers in the copy command. The attackers connected drive Z to their directory and we found the folder name in Korean, which meant to tamper. The attackers also managed and controlled each impacted system by server name and identifier. We also identified the open tools that were frequently used by the attackers. We found that the tools as shown on this slide were used to collect information of the impacted system. This concludes my presentation. If you need more information, please refer to the paper along with the presentation material. Thank you.